Hey guys, so welcome back to another video. So today I'm going to be talking about the definite integral, and I'm going to be going over kind of like an interesting tidbit about definite integrals. So up on the blackboard right now, you can see that I have two different functions up there. So I have the graph of f of x and I have the graph of g of x, right? So let's say for this question, I am given that the area under the curve between 0 and 3 of f of x is 6, right? So what that means in like math language is the definite integral from 0 to 3, right? Because that's what area under the curve is, of the graph f of x, or of the function f of x, is equal to 6, right? So this area right here in the red, that's going to be equal to 6. Right? So let's say I'm given this information and now I'm asked, okay, well now what's the area under the curve of g of x? Right? So I want to know the area under the curve between 1 and 4 of g of x, which in math terms is the definite integral between 1 and 4 of the function g of x dx, okay? So now I don't know how to find the definite integral of g of x, right? I don't have the tools to do that because that that section bounded by the graph of the function and the x-axis, that's not a shape that I just off the top of my head, like I know what the formula of the area of that shape is, right? It's not like a perfect triangle or like a square or something I can easily take the area of, right? So since I don't know that, I kind of have to analyze the function a little bit more. And since I'm given the integral and like the area of the curve for f of x, I'm going to see if I can relate g of x to f of x, right? So right off the bat, I think we notice that g of x and f of x are both parabolas, right? So they're in the same family of functions. What we should also notice is that f of x is actually the parent function of a parabola, right? It's kind of like the most basic parabola that you got out there, and you can make pretty much any other parabola from that function, right? So with that in mind, I can use my knowledge of transformations, right? So you guys think way back to your pre-calculus or maybe your algebra classes, you guys learned about transformations, right? So what we can do is we can kind of move functions, right? And there's like certain things that we can add into the equation of a function so that we can reflect that type of transformation in the actual equation, right? So for g of x, what I should see is that, oh, okay, hey, I have like this -1 inside a parenthesis, right? What that means is that means I've taken my parent function, which in this case is the f of x, right? Because it's x squared. So since I have a -1 inside those parentheses, what I've done is I've taken my parent function and I've moved it over 1 unit to the right, right? So if you guys remember your transformations, if you have something inside the parentheses, you're moving left and right. If it's a minus whatever, you're going to be moving to the right. If it's a plus whatever, you're going to be moving to the left. So in this case, we have a -1 inside, so we're going to be moving 1 unit to the right. Since I've only moved my graph 1 unit to the right, my area doesn't actually change, right? I haven't done anything that would affect the area, right? Let's say if I shrunk the graph or if I made the graph wider, those would affect area. Additionally, if I move the graph up and down, those will also affect area because what I'm looking at with area is the area under the curve, right? So if I move the graph up and down, that affects the area under the curve, right? But if I'm moving only left and right, I'm not changing the area under the curve. That being said, I should also see that, okay, wait a second. The interval between 0 and 3 and the interval between 1 and 4, right? Those are both 3-unit intervals, right? So what that tells me is essentially I'm finding the same integral. It's just in a different place, right? So since all I've done is move my graph of f of x to a different place, from that I can realize like, okay, wait, I've just moved f of x 1 unit to the right. The area doesn't change, especially because I'm taking the area of the same interval, just shifted over 1, right? So since the area is the same, what I know is for this blue space right here, that area is equal to 6 as well, right? So this definite integral is also equal to 6, right? So I thought that would be a pretty useful piece of information for you guys. So if you have any questions, feel free to come see me during my office hours. If you want to practice your definite integral skills, I have a worksheet up for you guys. So yeah, that's all I have for you today. I hope you learned something from this video. But yeah, thanks for watching, guys.